The world is buzzing about electric vehicles. You see them everywhere now, don't you? Silent, sleek, promising a cleaner tomorrow. Demand is absolutely soaring. People want EVs, governments are pushing for them. The future, it seems, is undeniably electric. This transition is happening faster than many predicted. It's a wave of change, a powerful current pulling us towards a new era of transportation. We are witnessing a fundamental shift in how we move. This shift is exciting, it is hopeful. But here's a fascinating twist. The very materials needed to make EV batteries, their prices are falling. Yes, falling, significantly, skyrocketing demand for the final product, yet plunging prices for the essential ingredients. This is not what classic economics textbooks might predict. It's a paradox. A beautiful, unexpected paradox. It challenges our assumptions. This situation presents a puzzle. How can this be? More EVs mean more batteries. More batteries should mean more demand for lithium, cobalt, and graphite. So why are these crucial minerals becoming cheaper? It's a question on many people's minds. Let's dive in and explore this unexpected gift. Let's talk numbers, because these price drops are not trivial. Take lithium, the white gold of the battery world. Its price has tumbled. We're talking a dramatic fall, perhaps as much as 80% from its peak just a couple of years ago, in late 2022. Imagine that, a crucial component suddenly much more affordable. This isn't a minor market correction, it's a fundamental shift. It's a game changer for the entire industry. Then there's cobalt, another critical element, often sourced from challenging regions. Its price journey has also been downwards. We've seen it halve or even more in some markets. This reduction eases pressure on battery makers. And we cannot forget graphite, the unsung hero in many battery anodes. Not long ago, the narrative around lithium was one of scarcity. Would there be enough? Could we mine it fast enough? These were serious questions. The demand for lithium-ion batteries was exploding, not just for EVs, but for smartphones, laptops, power tools. Everything seemed to need it. This fear of shortage drove prices sky high. It created a sense of urgency, a race for resources. But the market responded. Innovators and investors saw an opportunity. New lithium mines started to come online, all over the world. Australia ramped up its already significant production. Projects in South America, particularly Chile and Argentina, expanded. Even China, a major consumer, boosted its domestic extraction. Suddenly, the supply picture began to look very different, more promising. Cobalt. It's a mineral that brings incredible energy density to batteries, but it also brings complexity. A significant portion of the world's cobalt comes from the Democratic Republic of Congo. This has rightly raised ethical concerns. Issues around artisanal mining conditions and child labor have been prominent. These concerns put immense pressure on the industry, a pressure to find alternatives, or to ensure responsible sourcing. This pressure has had an effect. The industry has been actively working on two fronts. Firstly, reducing the amount of cobalt needed in batteries. New chemistries like LFP, lithium iron phosphate, use no cobalt at all. Others use significantly less. Secondly, there's a big push for traceable, ethically sourced cobalt. Section 5. Graphite's gentle descent. The unsung hero gets cheaper. Graphite might not have the glamour of lithium or cobalt, but it's a workhorse in today's EV batteries. It's the primary material used in the anode, the negative electrode. Its role is crucial for battery stability and longevity. For a long time, China has dominated global graphite production, both natural graphite mining and the production of synthetic graphite. This dominance gave it significant influence over prices. However, the graphite landscape is also evolving, just like with other battery materials. New mining projects are starting up outside of China, in places like Africa and Europe. This helps to diversify supply, reduces the risk of bottlenecks, and creates a more competitive global market. And that competition naturally can lead to lower prices, or at least more stable prices, which is good for everyone in the EV chain. Investment in graphite processing capacity is also increasing globally. Section 6. The global supply deluge. How nations are opening the taps. The falling prices aren't happening in a vacuum. They are a direct result of a massive surge in global supply. Several key countries are at the forefront of this production boom. China, for instance, has been incredibly strategic. It's not just a massive consumer of battery materials, it has also invested heavily in mining and refining them, both domestically and internationally. Their capacity to process raw materials into battery-grade chemicals is unparalleled. This scale brings efficiency and it helps to push down global prices. Then there's Indonesia, a nation transforming into a nickel powerhouse. Nickel is another key ingredient in many EV batteries, especially high-energy density ones. And guess what? Indonesia also has significant cobalt reserves, often found alongside nickel. The Indonesian government has actively encouraged investment in downstream processing, insisting that raw ores are refined within the country. This has led to a flood of new nickel and cobalt products hitting the market, adding substantially to global supply. And we must talk about the Democratic Republic of Congo again. Section 7. Riding the wave impacts on the electric vehicle ecosystem. So what does this all mean for the EV industry? Well, the most obvious impact is positive. Cheaper raw materials should translate into cheaper batteries. And since the battery is the single most expensive component in an EV, this is big news. It could mean more affordable electric cars for consumers. Imagine EVs reaching price parity with gasoline cars sooner than we thought. This would be a massive tipping point. It would accelerate adoption dramatically. More people could make the switch. This cost reduction also gives EV manufacturers more flexibility. They could choose to pass the savings on to customers, making their cars more competitive. Or they could reinvest the savings, perhaps into research and development for even better batteries, or into improving other features of their vehicles. They might also choose to increase their profit margins, which have been under pressure in the highly competitive EV market. It gives them options, strategic choices to make. However, it's not all smooth sailing, especially for the mining companies and material processors. While lower prices are great for EV makers and consumers, they squeeze the profits of those at the start of the supply chain. Section 8. Horizon Scan. The next generation of battery technology and recycling. The world of batteries never stands still. Innovation is constant, relentless. Scientists and engineers are working tirelessly on the next breakthrough. We hear a lot about solid-state batteries. These promise higher energy density, longer life, and improved safety. They could even use different materials, potentially reducing reliance on current sources of lithium or cobalt. Though commercial scale is still some years away, the promise is huge. Then there are other chemistries gaining traction, sodium-ion batteries for example. Sodium is abundant and cheap, much more so than lithium. These batteries could be perfect for stationary storage or for lower-cost, shorter-range EVs. This diversification of battery types is crucial. It means we won't be solely reliant on one set of materials. It creates resilience in the supply chain. It opens up new applications and new markets. And critically, there's recycling. This is a huge piece of the puzzle. A truly sustainable electric future depends on it. As more EVs hit the roads, more batteries will eventually reach the end of their first life, but these batteries are not waste. Section 9. Powering Tomorrow, our collective journey to an electric future. So, we find ourselves in an interesting moment, a moment of unexpected opportunity. The demand for a cleaner electric future is surging, and surprisingly, the essential building blocks for that future are becoming more affordable. This paradox of falling battery material prices is a gift. It can help us accelerate the transition to sustainable transport. It can make EVs accessible to millions more people much sooner than we thought. This is something to be optimistic about. The journey to a green future is rarely a straight line. It has twists and turns, it has challenges, and it has these wonderful, unexpected boosts. The current market dynamics for battery materials are one such boost, driven by increased supply from nations like China, Indonesia, and the DRC, and by the relentless pace of innovation. It shows that when humanity focuses on a problem, amazing things can happen. We can adapt, we can find solutions. But this journey is not one we watch from the sidelines. It's a collective endeavor. It involves innovators dreaming up new battery chemistries. It involves entrepreneurs building recycling plants.